title of this webinar is deliberately provocative, and we have a stellar set of panelists here to help us respond to the question, is open source software a national security concern? There is increasing attention to cybersecurity these days, most recently because of the horrific events taking place in Ukraine and the consequential internet-based attacks that are an integral part of those actions. However, this webinar was motivated by the many attacks and infiltrations in recent years leading up to the Log4j vulnerability late last year, a very common, widely used embedded piece of open source software. The White House was moved in January of this year to send a letter inviting software companies and developers to discuss ways to improve digital security in the cloud, pulling together participants for what they called an open source software security summit. In the invitation, they even went so far, Jake Sullivan, White House National Security Advisor, to note that it was a national security concern for foundational open source software to be maintained by volunteers. We're here today because we agree open source software is foundational to the internet. And while it may have some unique challenges, because everything's in the open and there are so many volunteers involved in the projects, we dispute the implication that open source software is somehow special or a national security concern. The fact is, many companies who build the internet's infrastructure do so by leveraging the incredible and pervasive work done by open source communities. We are all committed, users and developers of this open source software, to increasing the security of open source software so that we can all benefit, and that the foundation of our modern economy, the companies who use the open source software, we just don't see it as an inherent reason for concern. There seems to be an implicit assumption that closed source systems are more secure than open source systems. Well, we're here today because we disagree with that. There are benefits to open source systems that outweigh those perceived risks of open source. And we're going to focus here today on those perceived risks and the actual benefits of open source projects. As a reminder, this is an open discussion among the panelists. However, we do invite you, those of you who are present here today, to ask questions and engage in the conversation. The chat room is open. You should feel free to use it, talk amongst yourselves as much as we can. We'll also participate in the chat. If you'd like to ask a question, though, we do ask that you put it into the Q&A pod. Hopefully, we're all Zoom experts now. We've been using it for one of the many technologies very popular in these COVID times. So please use the Q&A pod and put your question there. We will certainly do our best to bring all of those questions into the discussion. So with that, let's jump right in. And I thought we would first begin by setting a little bit of context. And I think let's start with what exactly is an open source project. I'd like to ask each of our panelists to briefly describe, what that really means to you. What is a project? Who is the developer? What is the role of volunteers? What does that look like to you, and what does it mean to you? Let me just reach out to Ayla first and have you lead us off, and then we'll go to Brian and Jeff.
Sure, thank you. Thank you for that introduction there. So an open source project is kind of a spectrum or range of different types of projects, anything from a single developer that had an idea or a problem, they solved it, and they decided to share that with everyone on a platform like GitHub, all the way up to companies that take an existing technology, sometimes even a core technology they rely on, and again, share it with the whole world, meaning the sources available, the documentation is available, the people, the community, the worldwide community is able to participate by using that software, but also submitting patches and documentation, supporting it, etc. It's software that doesn't belong to one single person at that point or one single group, but it really belongs to everyone. and it comes with a wide variety of licenses.
So thank you. I like your emphasis on the fact that it belongs to everyone. You know, I mean, everybody gets a piece of all of that.
Mhm.
Brian, would you like to add to that, please?
Sure. I mean, in many ways, taking an expansive view of open source, it's older than proprietary software. In the days when mainframes ruled, they would come with the software source code because it was all in either bytecode or a COBOL or the like, which wasn't even compiled. And you'd pull it in and use it and be expected to be able to modify it, right? It was actually not until the early 80s when Bill Gates wrote a letter to the Homebrew Computing Club pleading with people to stop passing around his MS-DOS program distributed on floppies, that this idea of, oh, well, maybe there's an industry to build on proprietary software where you don't share the source code actually kind of took hold. And in fact, in those early days, there's an example of a project you wouldn't call open source, but in every tradition, almost every tradition which was called Vista, which was at the Veterans Administration, the software that ran the electronic health record system for the VA, was developed by government employees working at each of the VA offices, modifying mainframe code. They wrote their own programming language called MUMPS, and they were sharing this code back and forth between all the different clinics and hospitals to improve it collectively. Now, it wasn't shared with the public, but it was still shared internally. In fact, many years later, it was liberated and open source through a series of Freedom of Information Act requests, but we don't have to go there. Backing up more formally, it is a project governed by a valid open source license. There is a standard out there that describes what it is, but that's not the most interesting part. The most interesting part, I think, is how it serves, actually, the license serves as a guide to set up governance amongst a set of predominantly individuals, even if they're being employed by different companies to participate in that project. And on almost every case, you find that software is being built by people working on their employer time or working on something related to accomplishing a commercial task. It's really best if they're working together in a way that's open source, not just in the license, but also in the process, where it's not just the end result of some private kind of collaboration and R&D development, but actually all of the processes of development are public facing. And we see a lot of open source code that's either thrown over the wall by a single company or something that's like 100 lines of a single function that's spit out by a developer kind of in pursuit of a core project. Oh, this is the thing I thought other people would like. But I think those represent risks. Particularly security risks and infrastructure risks. And we can talk about that over the course of the hour. I won't go there, but about why I feel that way. But the most important thing to understand today about open source software is it's everywhere. A study done by Sonatype on the state of the open source supply chain notes that about 90% by their estimation of the typical application stack is open source code, even when it's a proprietary thing, even when it's a phone or automotive systems or anything out there, odds are 90% of that is open source code. And likewise with government systems, there's tremendous amounts of open source code running inside of government, and not just Vista, but lots of other examples of governments not only pushing out open source code and publishing it, but even starting to adopt open source first policies. France comes to mind. Happy to talk more about that. So it is critical infrastructure, as critical as roads and highways and national payment systems, electricity grids. I mean, this is really something that now we all have to focus on. It's why the White House obviously has paid attention to this issue and asked with Log4j, is there a real structural question here? I think the final point I'll make is it's not quite true that everyone on these projects is a volunteer, or even the majority of them. The relationships with the projects are voluntary, right? You know, you don't have to participate in an Apache project, right? But typically the people working on it are not working outside of their economic self-interest. There are quite a few companies that have said, this project's important to us, we're gonna put resources into it, it's critical to our infrastructure and our business. So even though we give it away, we're still going to fund that. And the best thing to do is try to aggregate all of those collective interests into a common whole that then lifts all boats. And that's what, by the way, I'm Brian Millendorf, Linux Foundation. I lead something called the Open Source Security Foundation. So we spend a lot of time thinking about how to channel this into building more secure software by default.
Thank you, Brian. I very much appreciate the history lesson in particular. You know, that the internet, foundational open source, it started with open source. The code was always there, and that's how we began. And then you ended with, you know, yes, it's everywhere. And we're going to get to speak more about that in a little bit. I also like the fact that you do mention that there is licensing involved, which is, it's an interesting thing to compare that to what, corporations do in proprietary software, because they have their own licensing. They license it in part by keeping it a secret, and it is just theirs, and they make money on it. So the licensing here has a different role in open source software, and hopefully we'll get a bit to an opportunity to speak a bit about that. Jeff, would you like to speak to the question of what is an open source project? And Jeff, you're on mute.
You would think after 2 years of dealing with Zoom all day, every day, we'd get this right. My God. Little tough going after Brian. You covered it. I wish I wrote that down and memorized it, because it would save me a lot of time in introductions. I'm the president of a company called ISC. We've wrote and developed and support some foundational pieces of the internet, and the person of Bind, which is a DNS name server for authoritative and recursive name servers, and DHCP, which is the way that you magically get connected when you walk into Starbucks or other places. So a lot of the real guts of the internet involved with what we do. The software is on the order of decades old, has thousands of authors, and is very widely used. Most of the commercial implementations of the similar versions, in fact, use our software in their commercial offerings. So the real main thing I think to think about when you're thinking about open source is, I'd turn the question around. Is closed source software a national security concern? Basically, a bunch of guys wrote software because it was necessary, and then somebody came along and decided to make it secret and start charging for it. And democracy dies in darkness and bugs grow in it. So I'd offer up, I'd never thought of this, but maybe we should call it the transparent software rather than open source. When you get software from us and you buy a support contract, you literally get the source code. So there's nothing hidden, there's nothing in there somewhere, there's nothing proprietary. Open source software is developed to do what it is supposed to do and visible to everyone. It is extremely difficult to hide any bad stuff in there because you're doing it all in public, in daylight, and it's all fully documented. So I could either write a book or do 2 sentences on open source. So you're asking me to do the middle, and it's not fair. It's not a matter of whether we use it or not, it's how best to use it.
So thank you for that. And with that in mind, since this discussion really is about security concerns and security issues in open software, let's jump to a question about your experiences, from each of you in dealing with security issues in open software. And to the extent that you can draw comparisons with how closed source software systems work and your own interactions in that space, that would be great. And so, Jeff, since you were last time, why don't we lead off with you this time to talk about your experiences in identifying and addressing security issues with open software and the feature that you see in that.
Okay, we have some number of instances of Bind out there, arguably 1 million, and each of those instances serve up to several thousand people each. So it is an extremely widespread installed base. We have security issues that crop up many times a year. We take care of them in a very orderly fashion. We have support customers who get a slight advance notice. It's an orderly process. Things are released on time. But I'm remembering back, I spent a lot of years in commercial software. And when you would find a bug and report it, there were several senior members of management who had large shareholdings who had interests in bugs not getting out or known to the world, because as I'd heard more than once, if you're not a little bit ashamed of your code, you ship too late. The thing I really like about being in open source, and this is absolutely true, is we have never, ever shipped a product that we didn't think was right, period. There is no shareholder, there is no stock, there's no press, there's no egotistical founder, there's nothing else out there. This is simply something that we do because we're driven to do it. We're all paid professionals. We're supported by people who believe in what we do and pay us for our work. But that's a really big deal right there, as far as I'm concerned, is the motivations of the people writing and supporting open source software are that the software work and that the bugs get fixed. That's a big difference.
Thank you. Thank you very much for that. Brian, you want to jump in there?
And apologies, it also feels like I'm going back in time and history, but in '95, what spawned the launch of the Apache web server project was a group of us who were early webmasters using the NCSA web server that developed by the same group that built Mosaic, and it worked great for our needs. It was open source, so they didn't call it open source. The term open source didn't even come about until 1998, but we were starting to use it, but all the student developers at NCSA one day left to go join this new company called Netscape. And those of us who were using the code, we were kind of able to support ourselves, able to kind of, fix the occasional bug here and there. And then there was a bad security hole that came up. This was before CERT even started issuing numbers, before lots of other problems. Just there was a post on a something called the bug track mailing list, I think it was at the time, maybe it was a different one, saying, hey, there's a hole in this. And we started to realize, well, who's going to push out an update of this code, right? And there had been patches floating around to fix it, but nobody at home at NCSA to release an updated version. So we kind of recognized as end users that our own investment into this code, which was incidental. None of us wanted to be full-time web server developers or anything like that. We were building more interesting websites, but we had to have this sense of collective action, not just to work together to fix the small bugs, but also some collective responsibility around the big bad bugs. And so that was really the launch of the Apache web server project. We put out a new version. We obviously chose a different name for the software rather than calling it NCSA version next or whatever. But that sense of collective responsibility is something that I think the better run open source projects all have, a sense amongst a group of maintainers that, even if you didn't write that code, collectively, you're still responsible for it, and this kind of bleeds out and should bleed out if you design it well into the user community as well. We talk about the software being free software, but it's not free as in beer or free as in Gmail, as I like to prefer to call it, but free as in puppy. There's kind of if you're using it, depending upon it, a responsibility to jump in. And I think that often gets lost. And there's lots of reasons for that we can dive in, but I think it's one reason we all took Log4j for granted in some ways, depended upon it in core critical infrastructure without dropping a dime to add to it. And so what I think is really important today in 2022 is that we start to infuse how developers choose which software packages to use based not just on features and not just on the history of recent releases, but what's going on in that project in terms of how well they're managed, how well they respond to bug reports that are coming in, what other practices they take proactively to try to lead to more trustworthy software.
Thank you. Thank you. Ayla?
Sure, and I'd like to touch on some of the same points that Brian raised right at the end, talking about what I'll call how healthy a project is. Are the developers in that project, are they responsive? Do they respond to email or IRC or Discord or whatever communication medium they're using? Are they responsive? Do they put out releases? And as a person, as an individual, but also someone that works at a company that relies a lot on open source software, our ability to assess, hey, this project is healthy, it is something that we can participate in. When it comes to security, that is very important, because with open source software, we as a user or a consumer, that end part of the chain there, we can participate in the software, in its development, we can participate in improving its security. So when we do ourselves find, say, a security problem, a security defect, and we report it, we can work with that project to come to a solution. With closed source, you may find a bug, you may find a defect, but you don't get that same level of participation. You don't have that same way of assessing, well, really how healthy is this software? Sure, it's available and they charge me a a monthly or yearly fee or whatever it is for it, but like, they don't tell me what got fixed and when and how it may impact me. They don't work with me as their customer to improve the overall security profile. That is a big advantage that open source or transparent source software has versus the closed source, is that level of participation, transparency, and ability to assess that the actual overall health of the software of the project.
So thank you, Ayla, and thank you to all three of you. I mean, there's some common themes that I heard in here. I like the use of the word transparent. That's kind of a new way to think about open software, because in a security sense, that really is a benefit to security in particular. There's a principle in security about security through obfuscation is not security at all. I mean, you simply can't hide. That doesn't, you have to know what you're doing. You have to know how to do it. And I like the phrase about collective responsibility. That's what you get with open source software. It's not just about, the company that might be making profits. It is also about the users, to get to Ayla's comment about, whether or not that your provider and vendor is really solving your needs, is really addressing your concerns and whatever it is that happened to you. You get this opportunity to share in the responsibility, to actually see that your needs are being met, and that everyone has a role in that. I also like the phrase "free as a puppy," free as in a puppy, because you're right. There is a responsibility. It's a collective responsibility, and we all share. It's true that you can outsource all of that, just hand it off to a commercial company. That is a valid choice to make, and people like to make that choice. And we certainly shouldn't deny them that option. But the benefit of open source is, in fact, the collective responsibility. Instead of a singular point of control, you now know that you are being looked at and you're being reviewed, and everything that you've got in place is part of the community at large. And I think that's an important thing to call out, an important benefit for open source as compared to closed source systems. And it brings up a question for me. We've been talking about, people do use open source, and there are a lot of companies out there, commercial organizations that use it, and the internet has been built on it. What about the government? What is the government's role in open source? And let's first explore, although they have opened up this question of, some perceived security concerns with open source. We're sitting here now saying, well, not so much. We don't think so. There's some benefits here to how this is managed. But in spite of their alerting us to their concerns, are they using open source just like commercial companies? Is that present in the government, and what role does it play? Can you speak about your experiences with that? And let me start here with Jeff on that one, and others can jump in as we go along. And mute, Jeff.
Sorry about that. I'm 6 hours jet lagged as of last night. That's my excuse, and I'm sticking with it. Is there a public spot I could put a link on this that the participants would see?
In the chat.
In the chat. Okay. I would really love to put in a connection there from the Chief Information Officer of the US DoD that is about open source, and it's an FAQ that I thought was remarkably appropriate for exactly this point. I can't believe I just stumbled on it this weekend, but if you can see that there in the chat, that answers an awful lot of questions I'd been curious about, and it does it in a way that, believe it or not, it's actually kind of funny. It answers questions like, is this just put together by high school students? What is the legal basis of OSS? Can government employees publish an open source product, and how they can do that? So I'll point you to that, but that's way too much reading to do online right now. The short answer is we have government related customers both in and out of defense, closer to the research side of the world, around the world, that use open source, use it well, we believe use it securely. Some of them pay us to use it, some of them don't. And I know of no incident in which there'd been anything, troubling from a security point of view. It's a well put together, very, very transparent product. It was commented in the comments cleverly, and I appreciate that binaries are often used for distribution and you don't get the source code. One of the old-fashioned things about our software is you can literally sit down and read it. The source code is published. We'll also do it in a variety of packages, but the source code is there for those who have reading glasses and a pot of coffee.
Thank you, Jeff. Ayla, Brian, either one? Who's first?
Go ahead, Ayla.
So earlier in this webinar, one of the panelists mentioned that, I think it's you, Brian, that open source predates closed source. So if you think about it from that perspective, governments, not just the US governments, but worldwide, are already using open source software in one way or another. It's in everything. Even this Zoom client or Zoom platform we're using has a lot of open source components to it. So open source is there, governments are using it. Sometimes they are participating, like the NSA in the past has participated with encryption technology, with software like OpenSSL and others, whereas others have been more on the consumer side, not implementation, but deployment side, and some participation in the project. So just like with commercial companies, governments are already using it, and how they participate in those projects varies.
Yeah, thanks, Ayla. I wanted to add we are seeing tremendous use of open source software by government, whether it's in pieces that they pull down directly from GitHub, which is probably on the small side, but very much in the software that vendors deliver to them. And in fact, the government is starting to realize that getting these black boxes of software, whether delivered as stuff they run on their servers or on SIPRnet or otherwise as provided by a cloud provider. They can't just have these black boxes anymore. In fact, Executive Order 14028 from last May stipulated that government needs to move in the direction of mandating software bill of materials labeling on software packages that they either receive or even consume over a network. And that's because they want to know the next time there's a major security vulnerability in a component like a Log4j. They didn't know about this last May, but they certainly knew about it in December. They want to know where are not only their own systems vulnerable, but potentially even the systems of their vendors, right? And so I think we're going to see this kind of breaking apart of these black boxes, this idea that software as delivered is inscrutable, whether it's in binary form or not. Sometimes you can't read source code because it's so convoluted, right? But this idea that and it aligns very much with the FTC's right of repair kind of directions as well. This sense that maybe we shouldn't accept technologies that are just delivered as fait accompli and instead expect to be able to tease them apart, to repair them, to fix them, to hack them, to improve them. I think that's really good. But back to government use. I mean, it's been authorized formally by the DoD since a 2003 memo that basically stipulated open source is COTS. It's equivalent to commercial off-the-shelf software, as long as you commit to either supporting it yourself as an agency, as a branch of the military, et cetera, or finding a vendor who will sell support to you, right? Completely reasonable. And then really that was just recognizing what had been going on under the covers already. I mentioned Vista, of course. And I'm really encouraged by where the current government, the US government, is heading in this direction. Robin Carnahan, who was appointed as head of the General Services Administration, led a research group at Georgetown just prior to moving over at the Beck Center, focused on getting governments to collaborate on open source code and using open source, working with others to develop it. In fact, the right frame of mind might not to think about how does the federal government use and consume open source code, because they don't really have a peer out there, right? But ask, why aren't all state governments collaborating on open source software to run their Department of Motor Vehicles, right? Why aren't they all working on software and standards to identify, public benefit recipients so that we can fight fraud in major public benefit programs, right? There's lots of efforts to try to address this that are still focused on centralized services, centralized IT, where really the power of open source would be federating that out, decentralizing it out, and getting a lot more innovation going, and a lot of, frankly, I think a lot greater security as well. So anyways, and that's just the picture inside the US. I've already mentioned France and other countries adopting open source first policies that at their worst kind of align with techno-nationalism. And I think we might want to be on guard for that, but at their best really do speak to how do we make sure that we live in a world where technology comes from lots of different sources, is a really heterogeneous and innovative kind of domain. And that's why I'm really enthused about the adoption of open source in government and the direction we're heading in.
So thank you. You're touching into what I want to get to next. Let me first just capture a couple of things that I've heard here and just bring them out and up to the surface. Just as a reminder, right? Open source really is everywhere. And Ayla sort of emphasized it here, and Brian, you supported it again too. Sometimes it's just in components. You don't have to think about the whole system is an open source system, but there are embedded components. There are pieces that they draw down. I mean, going back to the Log4j, vulnerability that happened, that's just a component that turned out to be used in, wow, just everything. So widely deployed, widely embedded. And so it simply became a risk just because it had been there for so long and no one had noticed the issue. But the important thing is the issue was addressed, and it was widely addressed and widely known. And the vulnerability was called out. I mean, there was, as Jeff said early on, an ordered process by which the security issue was dealt with. And it was transparent, and we all know, okay? And everybody knows. And so you know that you have to do something. So, security needs visibility. Transparency is important. Open source has that benefit, which closed source does not. And you know that security issues are dealt with, and you know that everybody's looking for them. All of the users are. That's that collective responsibility part of it, and the shared responsibility. But I think there are two interesting, things to kind of jump to here. I'd like to give each of our panelists here an opportunity to speak about this. But, what can we do more directly with each other to identify the challenges that might be inherent in securing open source software? Open source software has we might call it a burden or a feature, maybe you want to speak to this, of when vulnerabilities are found, they kind of have to be addressed. You don't get to just hide them a little bit or wait to deal with them or not really deal with them and cover that up. Proprietary software, they can really do what they want. So given that the government is using open source software and making extensive use of it, what can we do to bring ourselves closer together and work together to deal with these challenges that are there, and maybe in a way which is better than what you get with proprietary software? So who would like to jump in first, rather than my tagging somebody?
I'll start with three things. It's not necessarily an exhaustive list, but there's I think one key to this is education. There are most people in software are self-trained. There's great computer science programs and code academies and all that kind of stuff. But most people I know, even up to senior software engineers, learned through man pages and O'Reilly books and all sort of kind of experiences. They go journeyman kind of style, right? But very few people stop to take courses in software security and thinking about adversaries, thinking about attack vectors, right, on the code, and following the kinds of forums like the comp.risk Usenet forum from the early 90s that I used to follow that would talk about how software breaks down and fails and how to and how you should be defensive about that. So the Open Source Security Foundation published a set of software courses on edX last year. We've had thousands of people take this course that addresses kind of key deficiencies, but really key things you need to know when you're building open source code about how to build more secure code. That's content that it only takes really a couple of days to fully consume. There's even a certification you can get at the end of that. But it's the kind of thing that increasingly people are saying, this is the kind of thing all open source developers should know before they release code, right? It might even be the kind of thing you start to see companies start to mandate of their own employees before they contribute to open source projects, or even maintainers on projects might be required to prove that they know this kind of content, right? So this is something we're really eager to get out there and get more people consuming, and it's all free, of course. The second would be monitoring. We have very poor tools now to assist software developers when they're picking dependencies and picking frameworks and infrastructure to build on top of. How do you judge if I've got two Java logging frameworks, which one is more likely to meet my needs? I can look at the list of features, I can look at the number of stars on GitHub, right? But what are some other ways that I might want to tell, when I have to really dig if I want to figure out when was the last release that addressed a security hole? Are there outstanding CVEs against it, right? Or outstanding CVEs against underlying dependencies? But even more so, how do I come to an understanding of, Log4j, for example, had a really unsafe practice, parsing user submitted input for format strings. This is something actually the training materials we published recommend as an anti-pattern. Don't do this, right? And had the Log4j developers read that and followed that advice, they might not have put this chainsaw in the middle of a dinner cutlery set. So I think part of this is understanding systematically, how do we look at the state of these open source projects? And there are some objective tools to do this. At the Open Source Security Foundation, we have something called security scorecards developed by the community that look for, it's a systematic tool that looks for things in your build environment that suggests, okay, you've turned on testing with fuzzing tools, so that's a step above what other projects do. As an example, there's also something called the Best Practices Badge from OpenSSF, which is a checklist that maintainers go through to say, yes, we have a security team. Yes, we have a coordinated vulnerability disclosure process, those kinds of things. And then if you have those, you can carry a badge on your project to help, again, guide decisions. And we see other vendors starting to introduce dashboards to kind of help you understand the software you're using, where the vulnerabilities are. I think something that spans across the full open source community would be really useful there to help with that decision making and help enterprises understand the risk that they're stepping into around open source. We should be under no illusion that all open source is secure, or that necessarily, with enough eyeballs, all bugs are shallow, but that presumes enough eyeballs. And there's way too much open source code out there that does not have enough eyeballs. So the third part of this, I'll just throw out, is one of the most effective tools to really lead to more secure software, frankly, is a third-party code review. Having an outside party who has been vetted, who has a history of being able to do this well, come in and review, your code, not just line by line for an off by one error, that leads to a memory hole compromise or whatever, but also can kind of challenge your fundamental assumptions about your threat model, right? So this is something that we've started to fund from the OpenSSF third-party audits of some of the major open source packages. It's something Linux Foundation projects that are well enough resourced do for their own code. That's something some of the other open source projects out there do, but frankly not enough. So what would it take to scan the top 300 or 500 open source projects every year with a third-party code review? Probably much less than it took for all of industry to respond to just the Log4j incident. So this is something we're starting to think about. How do we organize more of this, do more of this proactively for open source projects, and work with maintainers to get much more rigor into their thinking about how security applies to their project?
So thank you, Brian. I want to just expand on one little thing you said. Your last point about third-party review. One could start with the idea that, well, open source is third-party review. Everybody is reviewing it and always looking at it. But the piece that's missing, and I think the piece that you really wanted to get at, was lack of structure. It's not a structured review. It's just an ad hoc, incidental review of what's going on. Something is discovered. I mean, there might be bad guys looking for things in the software, but that's not helpful. What you want is a structured review. I just wanted to emphasize and call that point out. Ayla, Jeff, you want to add to this?
Good Lord, that mute button. Obviously, the testing is important. Testing costs money. Testing takes people. I think when you get a commercial product, you go through an evaluation process and you get the product and you buy the product, you install it, you sign contracts, you pay bills. The problem with open source is that process has changed around. You basically try it, you run it, you use it, and there really never comes up anything other than there's sort of an implicit license attached to it, but the money doesn't change hands, and the support issue only comes up when you go, hey, something broke, what do I do? I've always thought it would be really clever of any government organization to just throw in a best practice and say, if you're doing something that's relatively dependent on a piece of open source software that has a developer of it who provides a cost-effective support program, you should pay for it. Just like you're not going to run 1,000 seats of Oracle and not pay for it. Why would you run 500 instances of Bind and not pay for it? So it's kind of obvious, but it's kind of tough. The concept in economics is an externality, where everything has a price and everything has a need and everything has a supply and everything has a demand. Open source kind of breaks that. So you have to stop and remind yourself, just like you have to remind yourself, nobody's going to fine me for missing the trash can with this litter. Nobody's going to come and charge me in the middle of the night if I don't pay for open source software. But at some point, Heartbleed or a Log4j or something is going to come along and bite you, and you need to figure out how to decide to pay for that. So if I could ask my own government, what would be a helpful thing to do, throw in a best practice somewhere that just says, if you're using open source products that are developed by companies that are willing to support them, think about supporting them.
Thank you.
This has been a paid commercial message, obviously, but
no, I mean, open source, I mean, it is fair to acknowledge in general that open source in some ways, the overall economics are different, and yet at the core, the software has to be paid for in some way. You know, I mean, the software may appear to be free, just like the internet is free, right? Or as Brian said early on, free as a puppy, you know? Sure, you can get free puppies, but it's not really free. It has to be maintained. It has to be cared for. Open source is really no different. And it is fair to acknowledge that if you're using open source, it's only fair, especially if you're making integral use of it in any, you know, substantive way. You should give back. You know, I mean, open source is not there to just be taken and abused in that way. One could call that abuse. So I jump in on that. Oh, go ahead, Jeff. Do you want to add something?
Yeah, I was thinking about it as an analogy where I have talked to people who said, if you're not paying a guy in a suit with a corporate office millions of dollars a year, you're not getting the best service. And I was thinking about the core of American democracy is millions of volunteers, November 4th or whatever day it is, whatever year, getting out there and making cookies and making sure people have a right place to press the ballot and all the rest of it. And in the last year, we have found out what an incredibly fair and reasonable process that is, made up of millions of volunteers who just care a lot. And if anybody thinks the voting system would work better if we put out a bid to see between Oracle or Amazon who should run the elections, I'd have an argument with them. So, you know, the idea that somehow paying a box money fixed something, I think implicitly runs counter to some real bases of this country.
Thank you, Jeff. Ayla?
Sure. So as I listen to these responses, I have a QA background, and it is just like screaming at me right now that software defects are a fact of life. Software gets more complex, more complicated. It's no longer just like one module with 100 lines of code. Now it's millions of modules from all sorts of components and open source software, and it's a fact of life. Software defects will happen, and it's great. We should invest in education, like Brian said. Let's continue to improve the quality of the software that we write, because solving the problem at the point of writing it is always going to be the best and the cheapest, however you measure cheap, cheapest time to do it. But my QA experience is, even with experts, we will still find mistakes down the road because knowledge is not static. our skill at building these systems is not static. It's a continuous process. It's a journey. It's education. So when those defects do happen, how do they get resolved in the most effective and kind of the best way possible? And that comes down to the communication and collaboration between the open source component, whether it's the Apache web server, or if it's Bind or XM or OpenSSL, whatever that project is, and the people, the companies, the groups that are depending upon that. How do I get my software update to you? And once you receive it, do you have a process in place? Do you have a means in place of deploying that and knowing where you need to deploy it in kind of the least time possible? And working with different open source projects over the years, that's collaboration, that communication tends to be the harder part, because the more people you have involved in it, of course, the more, hey, I can't do this on Thursday, can we do it next Thursday? The whole scheduling and logistics pops up. However, it's that collaboration that really ensures that once that defect is known and fixed, that it can be deployed in the most effective way. So just my comment here is having that process in place and being actively involved in some way with the open source projects, so that when those security problems are found and fixed, that you are also part of the process in putting them in place in your project, in your company, your organization.
So thank you, Ayla. Let me try and bring forward here and kind of summarize 3 key points that I have in my mind, and then we'll jump to moving towards talking about next steps. What do we do next? You know, what would be our advice for the future here? I think that we have tried to make the observation that open source software certainly functions and is created and developed in a way which is very much like closed source systems. There really is no fundamental difference there. They have the same set of problems, the same set of issues, and they deal with them both very effectively. There's some very successful open source projects, and so singling out open source as having some kind of concern because it is open source just has no data to support that. At least we haven't, presented any here or suggested that there is any. The second thing is, I think a key feature of open source software is the fact that it is transparent and it is open source. So there is a collective responsibility. Everybody has a chance to see what's going on. Everybody has a chance to check whether or not their needs are being met. Everybody has a chance to review the software, to see if whenever they've had a problem or concern, it's dealt with. So all of that is just visible and open and transparent. And that is a benefit that open source has uniquely. Closed source systems don't have that benefit. You don't have collective responsibility. You have a single point of control, and you're driven by, whatever they say and whatever they're doing. That doesn't have to be bad, but it is fair to acknowledge that, there is a shared role and you have the opportunity to check. You have that balancing opportunity that you don't otherwise have. And the third thing that I would observe is that the security of open source software, because of that transparency, it does have a certain benefit. You get a certain timeliness and you get a confirmation about security issues being addressed. You do know that your concerns are going to be looked at. You do know that there's going to be an opportunity for you to get a response to that security issue. And then just as, you can leverage off of the transparency that you get because you get confirmation. You know that it's not going to be dismissed or disregarded. And in fact, open source projects welcome the opportunity to take care of their customers and to take care of their software. They take that responsibility very seriously. They take very seriously this collective responsibility. So the question that I'd like to move to here given that I find it in a way, it seems it's ironic, as we've said here, that, the US government would suggest there's a national security concern here. I don't think there's any real difference. And plus, they're already using open source anyway. So what is the point that they're trying to get to here? There's a difference between asking for, how do we make things better, and then suggesting that we've got a real problem here that needs to be fixed. And I think that we're trying to state here that there is no real problem here. There might be some places for improvement, things that we could do. And so let's get to some of these next steps and steps that we could get to. I really want to kind of close here with two questions for each of the panelists and give you an opportunity to speak to this. What would you say is, what message would you like to offer to legislative officials who are concerned that open source software is inherently some kind of national security concern? Can you sum up a point in just a sentence? And then two, do you have any specific recommendation for how private and public sectors can do? What would you say is a good next step? Do you have one practical suggestion for what we could all do next in order to move forward? And let me go to Ayla first, and then we'll come back to the other two.
So could you repeat your first question, please?
What message would you give to legislative officials who believe that open source software is a national security concern? And then what do you recommend for a next step?
Sure. So my message to them would really be in the form of a question, which is, I'd like to understand what you're seeing. What is the concern? And not just like a vague high level statement, but show me the data. Show me what you are seeing so that we can have a conversation about it. And to your second point, get involved. If you see there's a problem, get involved. Get involved with the open source projects that you are dependent on.
Okay, thank you. Jeff.
Hey, I'm off mute. At the risk of oversimplifying, but if we're talking to a legislator with a simple message you want to have, if you can't afford to tip, don't eat in a restaurant. People who use open source software should be willing to pay for it. The better commercial companies do. I think the federal government, state governments simply need to make it easier for users in the government to do the right thing and pay for what they're eating. It's currently very awkward to put together a contract for support for open source software. Just make it easier. That would be a big help.
Thank you. Excellent point. Excellent point. Brian, bring us
On
home.
your first question, I think legislative officials and folks in government are very right to be concerned about the criticality that open source software has in the nation's infrastructure, right to be concerned that maybe the processes by which it gets developed aren't always perfect, and that can lead to small examples, small bits of code that can lead to outsized impact in vulnerability, and to ask what are things that government can do to be a part of taking that collective ownership, collective responsibility. So I certainly would not want to get the message across to them that, don't worry, it's open source code, there's enough eyeballs across every line, and it's all hunky-dory. In fact, it's this irrational exuberance around the security of open source code that sometimes I fear does lead us to taking things for granted. So now I'd want to harness that and channel it into some specific steps that I think government can do to improve things, in addition to some wonderful stuff already happening at CISA, at the Office of National Cyber Director's office around adoption of SBOMs, the Jenny Schuli's all hands on deck in terms of let's update what we've got. I think there's some things that were less helpful. The FTC, for example, issued a policy in the wake of Log4j that said that fines for cybersecurity breaches may be increased if they find that you did not remediate Log4j or if that was a vector through which you were exploited. So that's more of a stick rather than a carrot, I think, in terms of driving incentives for organizations to update. But I think there are some very useful things that government can do along the lines of the executive order from last May in terms of changing procurement policy to drive towards adoption of not just SBOMs, but things like signatures on software packages. We have a project at OpenSSF called SigStore, which is about adding a greater level of attestation, greater level of integrity to the distribution of software artifacts. Another thing along with that called SALSA, which is about the supply chain and levels of attestation as software goes through a supply chain so that you end up with something that you can have a varying degree of trustworthiness in. That's something that government could drive and really help in all of industry adopt, much the same way that California automobile emission standards drive the automotive industry collectively as a whole to increase their fuel efficiency. I think there are some opportunities for not a small amount of money, but we're not talking billions of dollars, but hundreds of millions a year being applied to things like, what if we did try to do a third-party audit of every major being, say, the top 200 or 300 open source projects out there once a year as a government service, where the benefits of that certainly go to everybody, certainly go to all of US industry, go to a global audience as well. But I bet still it ends up being less than the cost of remediating Log4j was. And then finally, again, back to this education point. If we can make that more of a priority and a principle in not just the formal education system, not just through community colleges, but also informally, how people are vetted as developers. We are all, again, very self-taught in this industry, and that's wonderful. That's good news in terms of accessibility. But let's see if there's ways that we can add to that corpus of knowledge that developers are expected to have when they write code about how to do so defensively.
So thank you, Brian, and thank you to all of our panelists and those who are still with us here. I know that we're just over the top of the hour, and I want to be respectful of people's time. We opened this session with questioning and disputing whether or not open software is a national security concern. I hope that the message that you've heard is that we don't believe that open source is in any way unique from proprietary software. And in fact, it has certain advantages over proprietary software in the security space. And then as Brian was closing there, that doesn't mean that it's perfect any more than proprietary software is perfect. So there are opportunities here to work closer together and to do more together to improve all of that. We've heard a number of suggestions here, not the least of which is just supporting open software openly and outright. Be a part of it, commit some resources, whether that's money or people to be a part of it. And Brian mentioned an additional set of opportunities there that, the US government can drive, as all governments can drive. They can be a leading driver of all kinds of solutions that will also serve competitive interest as well as open source. And we can devote a whole session to that all by itself at some point in the future. So thanks again to everybody. Thanks again to all those who participated. Special thanks to the participants. And with that, we are adjourned for today.